Here we go. 3.3, we're ready to roll. New way of doing a video. Rules for differentiation. You guys are going to be thrilled with the fact that you're going to get rid of the ADQ real soon. No, not totally yet. We got one more ADQ quiz coming up, and then after that one, we'll be using it to kind of figure out what the derivative of sine and cosine are, but we're getting close to the end of having to do the limit as h goes to 0 of f of x plus h minus f of x all over h. That's getting close to finishing, and you're going to be able to just take a derivative like that. Okay, so you're going to be happy about these rules. So, I'm going to use the notes that are already filled out. You can take the blank ones if you want and fill them out yourself. But I'm using the ones filled out just because in trying to make the video, I think I can go a little bit faster. And anyway, that's whatever. So, rule number one, the derivative of a constant function. It says if f is the function with a constant value of c, then the derivative of f with respect to x is equal to the derivative with respect to x of c, which equals 0. So c is the constant. So what they're saying is the derivative of a constant value is 0. That should make sense. Here's a constant function, f of x equals 5. All right? Well, we know that the graph of f of x equals 5 is just a horizontal line. And we know that the derivative, of course, is really just the same thing as saying the what? Slope. Good. The slope. So what's the slope of a horizontal line? It's 0. Right? A horizontal line has a slope of 0. I would hope we could ask Algebra 1 class to come in and help us if we need to. All right? So the slope is 0. So f prime of x is going to be 0. F prime of 5 is 0. The derivative of a constant, or a constant function, is always 0. The derivative of a constant is 0. That's rule number 1. It's the slope basically of a horizontal line. Next, rule number 2, the power rule for a positive. You don't have to know the names of these rules at all, okay? Just know how to do the stuff, all right? You will know a couple of the rules that you're going to get a little later today, but this is the power rule. You might hear me talk about it a little bit, but it's not a big deal about the name. Okay, so it says if n is a positive integer, then the derivative with respect to x of x to the n equals n times x to the n minus 1. Do you guys know what that means? Does that make sense to you? If I just left it at that, does that like immediately make sense to you? Yeah. Well, all they're saying is, if I want to take the derivative of x to a power, I take the power and bring it down next to it and multiply it by x. And then I take that exponent and make it what?
1 minus that.
1 less, right? 1 smaller. So an example, f of x equals x cubed. What's the derivative? Take the 3 around front. Now it's 3 times x. Power goes down by 1. It's 3x squared. Well, that's a pretty fast way to take the derivative, isn't it? As in the past, what did you do? The limit as h goes to 0 of f of x plus h minus f of x all over h and blah, 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 all that work. Now, the derivative is 3x squared. Ho-ho, that's pretty nice, right? So, the next rule is called the constant multiple rule. And it says, and you're going to see this a lot in calculus, so get used to it, okay? A lot of kids get confused by all the letters and stuff. If u is a differentiable function of x, so u is a function of x, all right? And c is a constant, then the derivative with respect to x of the constant times the function u is going to equal the constant times the derivative of u with respect to x. Now, what the heck does that mean? Well, here's one example. F of x is 5x to the 4th. That's a constant, 5, right? Times a function, x to the 4th. So in this case, in this particular case, u equals f of x, right? U is a function of x, but in this case, u is equal to x to the 4th. Okay? So it says u is a differentiable function of x, so u is f of x. But in this case, the function is the u is going to be x to the fourth, okay? So now, what if I want to take f prime of x? Okay? What if I want, now, don't get mixed up by this f of x and that f of x. I'm just telling you, I was just telling you that u is a function of x. In this case, the u is x to the fourth, okay? So I probably should have used a different letter, but anyway, that's that. So, this is a constant times a function, and the derivative is going to be the constant 5 times the derivative of x to the fourth, which is simply 4x cubed. And then you'll simplify it. 5 times 4 is 20, and it's 20x cubed. Now, what are you going to do when you actually are when you're actually going to be doing this? You're not going to really think about that. You're just going to bring the 4 around front. 4 times 5 is 20, x to the third. That's how you're going to do it. But technically, this is what's going on. And you need to understand that the derivative of a constant times a function is the constant times the derivative of the function. Now, number 4, the sum and difference rule. And all this says is, look, okay, now we've got not only u as a function of x, but v is a different function of x. So if we want to take the derivative with respect to x of two functions, added or subtracted, I simply take the derivative of the first one and the derivative of the second one, and I add or subtract the derivatives. Okay? What's an example of that? A polynomial. F of x is, here's one function, here's another function, here's another function, and here's another function. 4 functions added together to make one function, f of x, a polynomial. The derivative, take the derivative of that piece, which is 28, 3 times 8 is 24x squared. Take the derivative of this, negative 12x to the first, drop the exponent by 1, right? Take the derivative of 2x to the first, bring the 1 around front, times 2 is 2, x to the now what? 0, which is 1, so there's no x at all. And then what's the derivative of the constant 1? 0. And that's how easy it is. So far, this is looking like a breeze, right? Pretty easy. The only thing you got to worry about is making sure you know how to do the power rule, and all the rest of it follows suit pretty good. So let's take a look at the next piece, an example. Okay? Can you do, let's just do this real quick. Let's take this out of here, and, oh, it won't let me cut it. Okay, never mind. I thought I could cut that out of there and then put it back. All right, so what's the derivative of p with respect to t if this is the p function? That's just what we just got done doing. See if you can try it for yourself real quick without looking and see if you get the right answer. Maybe you're already done, but just if you're taking notes, try to do it without looking. And then look up and see if you got the right answer. But it's pretty simple. 3 goes around front, times t to the second, down 1. 2 times 6 is 12. Bring the exponent down 1 is 212t now. 5 minus 5/3, the t is going to be to the 0 after you drop it 1, and then the constant 16, the derivative is 0, so there's your derivative of p with respect to t. So, derivative of p with respect to t. So there's some good notation practice. I'm trying to state everything the way it's supposed to be read so that you understand that's how you're supposed to read, okay? Let's look at example. I guess the next one goes from example 1 to example 4. All right, I don't know what was 2 and 3. I'll have to look and see. All right, rule 5. Now we get into a little bit more difficult rules. There are some videos on Canvas. I think they're little videoettes or the little tutorials by that cartoon guy, you know, that did the what is a limit? The cars coming to the diner thing, you know. That's the same guy doing those videos. He made one on the product rule, I think, and I think he made one on the quotient rule. I know he made one on the quotient rule, and I think there's one on the product rule. You can look online. And you may not need to watch them anyway, but I'm going to show you right now. So if we have the product of two functions multiplied together, okay? And they could be any functions. But two different functions multiplied together. A mistake a lot of kids make is they forget about the product rule, and they'll just take, so if I got function f and function g multiplied together, they'll just take the derivative of f and the derivative of g and stick them there. It doesn't work like that for multiplication. It did for addition, didn't it, right? The addition rule, I could just take the derivative of each one separate and add them. For product rule, nope, doesn't work. The derivative of a function u times a function v is going to be what? Well, it's u dv dx plus v du dx. Well, how are you going to memorize that? It's easy. It's like this. It's the first times the derivative of the second plus the second times the derivative of the first. I want you to say that with me, all right? With me, out loud, nice and loud. First times derivative of the second plus second times derivative of the first. One more time. First times derivative of the second plus second times derivative of the first. All right? And if you memorize that, it's easy. So here is a function in which two different functions are multiplied together to make that function. If I want to take the derivative of that, yes, you could have multiplied all that out by FOILing, right? Simplified it and then just did a polynomial. But we're trying to show you the product rule. And I can't put in functions that you don't know how to take the derivatives of yet. Like, for example, you don't know how to take the derivative of ln of x, you don't know how to do sine of x or cosine of x. But if I had this times the sine of x, there's no way you can multiply it out and do it. So the product rule is very necessary. You will need it. Some derivatives, it's the only way to do the derivative. So don't think, oh, I'll just multiply it out. Well, this is one that you can get by without it, but a lot of them you can't. So anyway, f prime of x is going to be what? First derivative of the second, which is 3x squared, right? Plus the second, x cubed plus 3, times the derivative of the first, which is 2x. Then you do distribute it. Distributive property, 3x squared times x squared, 3x to the fourth, plus 3x squared, 2x to the fourth, and then 6x. Any like terms? The 3x to the fourth and the 2x to the fourth is 5x to the fourth, and then you got plus 3x squared plus 6x, and there's your derivative, okay? So in the last class, everybody good there? So you're going to need to memorize that. In the last class, I said, well, I kind of just made this up on the fly and said, well, what if we had a function like this, f 5x to the third times the square root of x. Now this is an interesting one because you're going to learn a couple of things here, which I kind of didn't really intend when I made it up. I just kind of threw it up there. If I use the product rule, you get g prime of x equals first 5x cubed times the derivative of the second, which is the square root of x. You remember the other day I told you I think it was in the video, I said you probably want to memorize what the square root of x is, right? The derivative of the square root of x. You want to memorize it. Did anybody remember that? Well, it's 1 over 2 radical x. If in case you don't remember and didn't bother to memorize it, you will memorize it probably naturally just by doing a lot of calculus. For, I think the first year I taught it, I never memorized it. I just figured out what it was, and I'll tell you that in a minute. But anyway, it's kind of good to know. So first derivative of the second, the derivative of square root of x is 1 over 2 radical x, plus the second radical x times the derivative of the first, which is going to be 15x squared. That becomes 5x cubed over 2 radical x plus 15x squared times radical x. And you think, well, can I simplify that? Well, you could get a common denominator, or you could rewrite the square root of x as x to the 1/2, and then that's going to be x to the 1/2 times x to the second, which is 4 halves plus 1/2 is x to the 5 halves. And then I got 5 halves x to the 5 halves plus 15x to the 5 halves. And then that's going to be, let's see, 30 over 2 plus 5 over 2 is 35 over 2 times x to the 5 halves. Those are like terms, okay? That's one way to do it. If you were to leave it in terms of radicals, there you could simplify it that way too. You'd have to multiply this by 2 radical x over 2 radical x, and that's another way to do it that I don't have written out right now, and I'm not going to take the time to do, but you could do that. But I do want to show you an alternative way of doing this derivative. You could avoid the product rule here too by changing radical x to x to the 1/2. And anytime you have a chance to avoid the product rule or the quotient rule, which we're going to learn later, it's sometimes it's a good idea because it makes things simpler. And I think you'll agree this ends up simpler. I can change this to x to the 1/2, and then x to the third times x to the 1/2 actually equals, that's 6/2 plus 1/2 is 7/2. Well, now look how easy the derivative is. 35/2, 7/5, 7/2 times 5 is 35/2, and then drop 1, so you're going to subtract 2 over 2 from 7/2, right? 7/2 minus 2 over 2 is 7/2 minus 1. That ends up x to the 5/2, and by golly, that's the same answer I had down here. Okay? So a little different way you could have done that. I would really almost like to take the time to get a common denominator here and finish that out, but I'm not going to take the time right now. But I think that would be fun. I'm really tempted to do it, but I'm going to move on. If I was at a chalkboard, I probably would. Actually, you know what? I'm going to do it anyway. My temptation, I can't resist. So I'm going to make this a green thing. Quit out of it. Oh, yeah, you can see what I write on here. So we're going to write 5x cubed over 2 radical x plus, if I multiply the other function by 2 radical x, that'll be 30x squared. And then radical x is going to make that an x, right? Yeah, over 2 radical x. And so then this becomes 30x what? That's 30x cubed, isn't it? Plus the 5x cubes. Okay, that's going to be 30x cubed plus 5x cubed is 35x cubed over 2 radical x. And is that equivalent to that? Well, there's my 35/2, and that's x cubed over x to the 1/2, which is going to be x to the 5/2, so it will be the same. Okay? All right, let's take a look, and now the dreaded quotient rule. The quotient rule is like the product rule, but it's harder. It's much more missed on a test. A lot of kids don't memorize it, and that's just laziness in my opinion. Sometimes kids will screw it up, and that's just an accident, but that's usually, again, they didn't memorize it because they didn't do the work enough and didn't bother. All right, what is it? The derivative of a function divided by a function. You can't just take the derivative of the top and the derivative of the bottom and be done. Yeah, there's a rule, just like the product rule. What is the rule? Well, when you read it, it's just v du dx minus u dv dx over v squared. Well, what is that? Well, it's just like the product rule. You got to memorize it so you can remember it. Denominator times derivative of what? The numerator minus the what? Numerator times the derivative of the denominator, all divided by the denominator squared. So let's have a little bit of fun here. Let's say that out loud. Ready? Denominator times derivative of the numerator minus the numerator times derivative of the denominator, all over denominator squared. One more time. Numerator times derivative of the denominator. Whoa, I screwed it up, didn't I? And how did I catch myself? Yeah, I did that on purpose. How did I catch myself? Okay, how did I catch myself? Because I said numerator, and I knew right away, I can't start at the top. When you get a job after you graduate from college, are you going to interview to be the CEO of Procter & Gamble, or Tyson Chicken, or Chick-fil-A? Huh? Are you going to be the CEO? Are you going to interview to be CEO? Right? Like, no. Where do you have to start when you start your career? You got to start at the frickin' bottom, right? And you got to work your way to the top. And that's the same thing with the quotient rule. You start at the bottom and you work your way to the top. So by doing my little hand things here, that helped me realize, whoa, I just screwed up. Okay? And I did do that on purpose. Actually, I didn't. Dang it. Okay, so anyway. All right, so, but I did catch me. All right, so it's denominator. See, that might help you remember. It start at the bottom. Denominator times derivative of the, oh wait, you're supposed to do it with me. Denominator times derivative of the numerator minus the numerator times derivative of the denominator all over denominator squared. Okay, that's what you got to have memorized. All right. So here is a function. We have to use the quotient rule. Okay, and the quotient rule says denominator times the derivative of the numerator, which is 2x, minus, oh, every once in a while I get a kid that puts a plus there instead of a minus. No, it's minus. Okay, minus the numerator, x squared minus 1, times the derivative of the denominator, which is 2x, all over denominator squared. You do all the math, you work that out with the distributive property. Distributive property, be really careful here because this is a negative 2x. You notice I rewrote it. I found myself over the years, I've made a lot of mistakes because this is on the other side here, and you forget about that negative right there. That negative is going to make that term negative, and it's going to make the second term what? Positive. And if you have to, do what I did up here, rewrite it as a negative 2x times x squared minus 1, so you can say, okay, negative 2x cubed, and then a positive 2x, all right? Cancel these two terms. 2x and 2x is 4x. The denominator squared on the bottom. Done. Quotient rule. You nail it. Okay? That's how you do it. All right? Got to be careful though. You got to memorize it first or you don't have a fighting chance. All right. The next one. Does y equals x to the fourth minus 2x squared plus 2 have any horizontal tangents? And if so, where? So, we've got a function, a fourth degree polynomial, right? We want to know, are there any horizontal tangents? Well, I'm guessing there probably are, right? It's a what? It's a polynomial. It's a fourth degree. We know the end behavior is like this, right? So it had to come down and go back up at some point, and it's a smooth curve, so there has to be at least one horizontal tangent. And there could be more, right? Because it could go up, you know, like that, right? There could be 3 turning points. Remember the pre-calc? One here, one here, one here, one here, like that, right? So let's find out. How do I find out if there's any horizontal tangents? Well, guess what? If there's going to be a horizontal tangent, that means what? A horizontal tangent, when do horizontal tangents occur? They occur at maximum and minimums. If there's a maximum of a function, there's going to be a horizontal tangent. If there's a minimum of a function, there's going to be a horizontal tangent. And of course, a horizontal tangent, the derivative is what? What's the derivative at a what is the slope of a horizontal tangent? We already discussed it. 0. So all I do is I set f prime equal to 0 and figure out what values of x will give me a derivative of 0. So I take y prime, the other notation, I could have said dy dx, right? dy dx, or y prime equals 4x cubed minus 4x. How'd I get that? Well, 4x cubed, and then 2 times 2 is 4, so it's minus 4x to the first. I set the derivative, 4x cubed minus 4x equal to 0. Remember, the derivative tells us what? The slope at any point x, right? So the slope at any point x is 4x cubed minus 4x. I set that equal to 0, and I solve for x to figure out what values of x will make the derivative 0. I factor out a 4x, I'm left with x squared minus 1. Factor x squared minus 1 into x plus 1, x minus 1. And that means that x equals 0, x equals negative 1, and x equals positive 1. All 3 of those numbers will make the derivative equal to 0. Which means that at these x values, y will have a horizontal tangent. And that's because the slope of the tangent line is equal to 0. And so that's where we're going to have horizontal tangents. So that means we know that this thing is going to, come down. It's going to have a horizontal tangent at 0. Oh, I'm sorry, first at negative 1, then at 0, then at 1, and then it's going to go back up. And behavior like that. So if you graph the function on your calculator, it says what happens on the graph at the horizontal tangents. Well, we have mins and maxes. Use the window, negative 5 by 5, negative 5 by 5. I'm not going to do that on the calculator. I'm simply going to say, okay, look, I know there's a horizontal tangent at negative 1, at 0, and at 1. But I don't know where. It could be here, It could be up here, but those are the x values. So this thing could come down like this, and come up, and like this. But that thing could be down, it could be down here like this. Okay, we don't know where it is. I guess I could figure out that it does have a y-intercept of 2, doesn't it? So this one might be a good case right here. I'll just call that 1, 2. So since I know the y-intercept is 2, that would be a better model. But I do want you to see that it doesn't matter when you have a function. Do you realize that if you have a vertical shift to a function, it's not going to change the derivatives at all? Why would that be? Well, if that 2 right there was a 12, when you take the derivative of it, it's still going to be 0, isn't it? Right? No matter what that number is right there, when you take the derivative of a constant, you're going to get 0. So it doesn't matter shifting up or down. It's not going to affect the derivatives at all. At 0, you're still going to have a horizontal asymptote. At 1, you're still have a horizontal asymptote, no matter whether you're up or down. So that's a good thing to know as well. We'll talk more about that later. And give me my equation again, Donya.
X to the 4
Okay.
minus
Oh, you suck.
2x squared.
Can't use that. X to the 4
Minus 2x squared
minus 2x squared
plus 2.
plus 2. And window, they told me to use negative 5 to 5, didn't they? This is close enough. Screw it. That's good. Well, graph. Okay, so there it is, right? And I don't know, what did they tell me to do besides graph it? That's it? Just so we could see it?
Yeah.
Okay, so then we're going to go to second quiz. We'll go to our home screen, and we're going to take the derivative math 8 with respect to x of alpha trace, which gives me y1, and then we're going to do that at x equals negative 1, and we should get a 0 value. Now we got 4e to negative 6, but we all know by now, right, that's really 0, right? And if we do the same thing at and if we do the same thing at, delete, and delete again. So if we do the same thing at 0, they actually get 0 that time. And then I assume if we do the same thing at 1, we'll probably get that same value we did before, that 4e negative 6. But anyway, so there you go. It verifies it. I don't know why. I guess we did that just to make sure you guys could remember how to use your calculator to find the derivative. So that gives you one more thing on that. Now this is where we get into some good stuff here. Okay, I set my, here we go, good. So, it says, given y equals ax squared plus bx plus c, find when y has a horizontal tangent. You guys think you can do that right now? How would we find out when y has a horizontal tangent? Well, we just got done doing it. What do? We take the derivative and set it equal to 0. Can you guys take this derivative? Let's find out. Let's make this red so you can see better. Y prime equals what? What's the first term derivative going to be? 2ax. What's the next part? Plus b, and what's the last part? 0, because c is a constant. We're going to set that equal to 0, 2ax plus b, right? Now we got to solve for what? X. So that's a negative b equals 2ax. X equals negative b over 2a. It looks like there's a horizontal tangent to y equals ax squared plus bx plus c when x equals the opposite of b over 2a. Huh. That seems familiar. Well, I hope it seems familiar to you. Who can tell me what that is?
It's the height of the parabola.
Not,
Like it's the vertex.
it is almost.
No, x value.
Now you got it. This is the x coordinate of the vertex of a parabola. Ax squared plus bx plus c, right? That's a parabola, quadratic, right? And we learned that the vertex, the x-coordinate of the vertex is always the opposite of b over 2a. Look at that. Calculus, look at the wonderfulness of calculus tells us that. They didn't just come up with that out of the blue. Calculus told us that, right? And you thought that was pretty nice to know when you were in Algebra 2, right? Because you could find the vertex really fast. Well, now calculus can find those places, right? That's how I got it in the first place. And they just solved, see, that's kind of nice because they just solved a generic equation that tells it for all. All right, that's pretty nice. All right, we have time for example 5. Supporting computations graphically. So, we've got this function, and we're supposed to take the derivative. It says differentiate, that means take the derivative. We took the denominator times the derivative of the numerator minus the numerator, derivative of the denominator over denominator squared. Simplified. I feel like we did this one a little bit ago. Now, we got to go back to our calculator, so I'm going to have to stop mirroring and go back over to my calculator. What I'm about to show you is how you can actually check to make sure your derivative is correct, okay? And you can use a calculator to do that.